Hello everyone, my name is Akshita Rajgiri and today I'll be presenting on the topic pooling layer. So pooling layer is the key concept used in convolutional neural network for image and video processing in deep learning. In this session we will cover what are pooling layers, why they are needed, their advantages, limitations and finally a short summary about it. So let's get started. Why do we need pooling layers? In convolutional neural network, convolutional layer extracts features from images such as edges, colors, and shapes. However, this convolutional layer generates feature maps that increases computation and memory uses. To address this issue, pooling layers are used. For example, an image has a feature like edge and textures. Pooling layer picks the most important features from the image so that it reduces the image size but keep the important features, making the model faster and more accurate. In simple words, pooling layer creates a summary of the data. It helps the network focus on essential information rather than focusing on the whole data. So what is pooling? Pooling is a downsampling operation used in CNN to make the feature map simpler and smaller. Instead of learning weights like convolutional layer, pooling performs a fixed mathematical operation over a small region. For example, a 2 into 2 window. It replaces each region with a single value such as the maximum or average, which helps the network become more efficient and translation invariant, meaning small changes in the image does not affect the result as much. There are mainly two types of pooling. First one is max pooling and second one is average pooling. Max pooling takes the maximum value from the each region and preserves the most important features. And second one is the average pooling. Average pooling calculates the average of all the values in the region and provides a smoother representation. So pooling helps the model make faster, less complex and less sensitive to small changes like shift and rotations of the image. We will see how pooling layer works. Step 1, input feature map. The feature map generated by convolutional neural network is given as an input to the pooling layer. Step 2, to select the pooling type. Choose the pooling method which you want to apply. For example, you can choose max pooling or average pooling. Step 3 is to set the filter size and stride. You can define the window size and how far it moves. For example, if the window size is 2 into 2, you can define its stride is 2. Step 4 is apply pooling. This window slides over the feature map. For example, if we use the max pooling, the largest value in the window is taken, and if we apply the average pooling, the mean of all the value is taken and then the operations are performed. The last and the final step, output pull the map. This step gives us the result in a smaller feature map that preserves the key features while reducing the unnecessary information. So now we will see what are the limitations of pooling layers. The first one is information loss. We know that pooling summarizes the data. Because of that, sometimes our detailed information is also get lost. The second one is fixed operations. Pooling is a fixed operation and cannot learn patterns on its own. The third one is excessive pooling. Too many pooling layers may oversimplify the features. For example, average pooling can sometimes blur important edges or features. And the last one is alternative needed. In modern architecture, some models replaces pooling with strided convolutional to preserve more information. Now we will see the applications of pooling layers. So pooling layers are used in many real world applications. First one is image classification to detect and classify object or faces. The second one is object detection to locate object regardless of their size or position. Third one is facial recognition to identify the faces despite small changes in angle or lighting. And the last one is medical imaging. In this, to highlight the important feature areas, reduces noise in X-rays or MRIs. So, to summarize today's session, pooling layers are essential part of convolutional neural network. They reduces the spatial dimension of feature map, lower the computation and makes the model robust to the minor changes in the input. The key takeaways are that pooling reduces the size of a feature map and max pooling captures the strongest feature. The average pooling smooths and generalizes the features and it overall helps controls overfitting and improves translation invariant. The example application is that image recognition task. Pooling layer ensures that the small changes in the image position or lighting do not affect the model's accuracy. And following are the future trends